So hi everyone, today we are going to discuss the assembly code to find the largest of 10 numbers. Okay, so you have 10 different numbers saved in the memory location, and then you are taking those values from the memory location and checking to find the largest of those 10 numbers. So you have from the question itself the information that you have 10 numbers, your count is 10. And we know that to perform any comparison, to perform any arithmetic operation, one value is has to be in accumulator. So the first thing is we are going to save our first value in any memory location wherever you're going to store the data. That first value we will move to accumulator. So for that, so the 25H is the location where you are going to save your first data. So your first data is in 25H, so let it be 06 or 07, 08, like that. Okay. Any value, you can store any value in these memory locations. So you are going to have values from the location 25H to 35H. Okay, 10 numbers in the in the next locations. The next 10 numbers in the next 10 locations from 25H. So you first save the value in R0 and then move your first value to accumulator. So the value which is there in R0 will be moved to accumulator. Your first value is there in accumulator. Now the count is not 10. When you start the count is 10. Now already one value is there in accumulator and your count is 9 now. So move R5, any register, you can give any register, okay, R5, 09H. So your count is 9 now. Now to take the next value, you must increment the location, right? Now the location is 25H. To increment the location, what we are doing is INC R0. So you are incrementing the location from 25 to 26. Okay. The next step is moving that value to another register for comparison. So here is our value. Where is the value? The next value is in R0 and I'm going to move that value to another register for comparison. Let it be R6. Okay. I'm moving the value to R6. R6 comma at the rate R0. So now the value in 26 will be moved to register R6. Okay, now what is the next step? We are going to compare these two values. Compare and check whether these values are equal or not. Okay, so the step is CJNE, compare and jump if not equal, accumulator, comma R6. So it will compare these two values and will take a decision. Okay, so what will be this decision? If these two numbers are not equal means either A is larger or R6 is large. So this is basically subtraction. A minus R6. A minus R6. So if R6 is bigger, the carry flag will become 1 and if the accumulator is 1, carry flag will be 0. So the logic is that we will compare these two numbers and then check the carry bit. So the next step where we are going to jump, where the L1 is going to is, let's write L1, J and C. Jump on no carry. Where we are going to jump? We will jump to another location L2 and if there is no carry, it will jump to L2 and what if there is a carry? There is a carry means R6 is bigger. So now we are going to save the value in R6 to accumulator. So what we will do? Jump on. If there is a carry, we will move the value in the register R6 to accumulator. Okay. Then we checked whether there is carry. We found that the second number is big or the first number is bigger than the second number. Now we are going to the next value, right? And before that, now the count reduced, we already took another value, count was 9 and then when we took the next value, the count is 8. So we have to reduce the count also every time, and we do this process, or we continue this loop until the counter become 0. So the next step is decrement and jump on non-zero. If it is not 0, which one is not 0? Or count. When the R5 is not 0, we have to repeat the process, right? We have to repeat the process. Now the largest number is there in our first location. Again we are going to check the value in accumulator. Always the biggest value is going to be in accumulator, and we will keep on comparing with all the other numbers. So it will go back to where? Here is back. Again we will increment the next to increment the R0, so that it will go to next location 27, right? Then we are winding up the program. Jump, exit. So we missed something here. We didn't write what will happen when these two numbers are equal. We wrote the code for when these numbers are not equal. So jump, where it will go to DJ and Z, right? So we are going to L2, and here is L2. Here also, when there is carry also, whenever there is a carry, whenever there is no carry, it will decrement the count, and then we'll check the or it will go for the next number. Hope you understood the concept. The logic is very simple, that you have a count, so you must give the count. Either you can write the step here, or you can start the program with the count. Then your first value is going to be in accumulator. You can save your second value in any register. Then you're going to compare these two numbers, whether both of them are equal or not. So when the second number is larger, there will be a carry, and if the first number is larger, then there won't be any carry. And then what you're going to check is a carry bit. Check whether there is a carry or not. If there is a carry, then it means that the second number is biggest. So you can save that second number in accumulator. So again we have the largest number in our accumulator. So when we end the code, our result is going to be in accumulator. Okay, the final result, the largest number is going to be in the accumulator. And every time when you perform all these functions, the step to do is decrement and jump if not 0. What is not 0? The count. Okay, when the count reduced to 0, the program will come to the exit, and the program ends. Okay, hope you understood. Thank you.